Hi again everyone. Today we're going to look at a basic problem from vector calculus. Okay? We're given some vector field and we're asked to calculate the divergence of f. Okay, so what does divergence mean? Well, loosely speaking, divergence gives a measure of the spread of a vector field. I'll talk a little bit more about that at the end, but this particular example is just a very simple, very basic example on how to calculate the divergence of a vector field. Okay, so by definition, the divergence of a vector field is just the dot product of these two vectors. Now, this is known as the del operator. It's not really a vector, it's a symbolic vector. Okay? Okay, so when we talk about divergence, we mean that this symbolic operator is operating on our vector field through a dot product. Okay? So, the divergence of our vector field will just be the following. Now, instead of using i's, j's and k's, I'm just going to write it out as an ordered triple. Okay, if you want to use I, j's and k's, you can, but you should put them in here as well. Okay. So now remember, with the dot product, the first component will multiply by the first component over here. The second component multiplies by the second component. The third component multiplies by the third component, and you add up all the bits. But remember, we're not really multiplying here. These are operating on the corresponding components. Okay? So if we expand this dot product, we'll get something like the following. Okay, ddz of x y squared z cubed. So all we really have to do now is take these partial derivatives, okay? So in the first case, we're differentiating with respect to x partially. We imagine all the other variables are constants. So in this one, we'll get yz. In this one, we'll get minus xz sine of x, y, z. And in the final one, we'll get 3xy squared z squared. Okay, so this is our answer. This new function is the divergence of this particular vector field. So a few things to acknowledge here. Note that this is not a vector field. It's a scalar valued function, a real valued function. Okay? Secondly, what does divergence measure? Well, like I said at the beginning of the video, divergence gives us a measure of how the vector field is spreading from a point. Okay? So, for example, if I calculate the divergence here and then examine the divergence at the origin, x equals 0, y equals 0, z equals 0, if I sub in those here, I get an answer of 0. Okay, so if this vector field represents, say, the velocity field of a fluid or a gas, then at the origin, the gas is neither expanding or compressing because the divergence is 0 there. If the divergence was positive, then you could interpret this as the gas was expanding at that point. If the divergence was negative, you could interpret that as the gas was compressing at that point. Okay? So divergence, one of the basic operations from vector calculus. Loosely speaking, it measures expansion and compression, and again, loosely speaking, it can be thought of as a type of derivative from vector calculus.